So here we're given the position vector of 2 points, A and B, on a line L, and we're asked to find the vector AB. So to find AB, we would say the vector AB is the difference of the position vector of B minus the position vector of A. And we can write the position vector of A and B in matrix notation. That's 2, -3, 5, and 5, 6, 8. So we subtract the I terms, the J terms, and the K terms. So 2 minus 5 is -3, -3 minus 6, -9, etc. So that's AB. So that's the first part of the question done. Now it tells us that there's another point, P, on the line AB, such that the magnitude of AP, so the distance between point A and P, is twice the distance between B and P. So that means P is either going to be here, where it's the distance between A and P is twice the distance between B and P, or it'll be somewhere down here, where again the distance between A and P has to be twice the distance between B and P. So obviously there's not enough space to put it here, but in an exaggerated sketch it would be either here or there, one of those two positions. And the question is asking for the possible position vectors of P. So let's start by finding AP and BP. So AP, so let's first find the position vector of P. So P is on the line AB, so you can start with the position of OA plus some constant times AB. And the position vector of A is simply 2, -3, 5. And AB we just found to be -3, -9, -3. So we can write OP as 2 minus 3 lambda. So I'm simply adding the I, J, and K components together. So -3 minus 9 lambda and 5 minus 3 lambda. So that's OP. And now we can say AP. So AP is simply OP minus OA. And we can substitute, we can do that all in one go because we know OP, we just found that. And we know OA, so this is OP, and OA is given in the question. So it'll be 2 minus 3 lambda minus 2, so that's -3 lambda, minus 3 minus 9 lambda minus -3. So that'll be -9 lambda and 5 minus 3 lambda minus 5 is negative 3 lambda. And then we can say the magnitude of AP, or the modulus of AP, is simply the square root of the sum of the squares of these terms. So it's 3 lambda squared plus, or I should really say 3 lambda squared plus 9 lambda squared plus 3 lambda squared, which equals to lambda root 98. Now we can find BP because that's mentioned in the question. So BP is OP minus OB. So again, we can do that directly by subtracting 2 minus 3 lambda minus 5. That gives me minus 3 lambda. Then minus 3 minus 9 lambda minus 6 gives me minus 9 lambda. And 5 minus 3 lambda minus 8 gives me negative 3 minus 3 lambda. And to find the magnitude of BP, that would be the square root of minus 3 lambda squared plus minus 9 lambda squared plus negative 3 minus 3 lambda squared. And that's equal to square root of 3 squared plus 9 squared plus 3 squared, so 99 plus 198 lambda plus 99 lambda squared. Now, we know from the question that the modulus of AP is twice the modulus of BP. Now, both of these terms have square roots in them. To get rid of the surd, we can say the modulus of AP squared is that all squared. So we can then say that 99 lambda squared is equal to 4 times 99 lambda squared plus 198 lambda plus 99. And that's really good news because now we have a quadratic and we know how to deal with that. I might have written 98 there, I meant 99. Okay, so now we can open up the brackets and move everything to one side, equate it to 0. We now have a quadratic equation that says something like 396 lambda squared minus 99 lambda squared plus 792 lambda plus 396 equals 0. So that's 297 lambda squared plus 792 lambda plus 396 equals 0. Use the quadratic formula. And that will give me two values for lambda. So lambda 1 is minus 2/3, and lambda 2 is minus 2. So that corresponds to the two possible position vectors for P. So remember, we said OP is equal to this expression here. So we can say OP, let's say OP1 is equal to, and we can replace lambda with minus 2/3. So we can say times minus 2/3 minus 2/3 minus 2/3. And that will give us 2 plus 2 is 4, minus 3 plus 6 is 3, and 5 plus 2 is 7. And OP2 is the same, using the value of lambda 2. So 2 minus 3 times minus 2, then minus 3 minus 9 times minus 2, and 5 minus 3 times minus 2. And that will give us 2 plus 6 is 8. Negative 3 plus 18 is 15. And 5 plus 6 is 11. So, unless I've made a mistake anywhere, these are our two position vectors for P, so OP1 and OP2, that satisfy this condition that we're given in the question.